So this is just a continuation of yesterday. Besides the example, this was the slide right before the example. So I just want to refresh your memory a little bit about what we were doing and how to find probability from a binomial experiment. So this is a combination from n things, the total number of trials, and x is the number of successes. Whatever the problem is talking about, we'll tell you what is a success and what is not. Then you have your probability of success to the number of successes power versus the probability of failure. And this actually is the power that reflects the number of failures. Okay? Since there's n total trials and x is the number of successes, that means the other group of trials that were not successes were failures. So another way to kind of think about this, I know it seems like a giant, nasty formula, but the truth is we're talking about an expression here that's all about success, the probability of it to the number of those successes, and this one is the probability of the failures to the number of the failures. Okay, so you kind of have those grouped together. So hopefully that's easier to kind of keep in mind, or to keep track of. Here's the example. If you want to write it down, if you want to take a picture of it, it's up to you, and we'll kind of go through this and talk about it. Actually, I want you to try to do this. Okay, try to do this problem. See if you can figure out all the different variables that are missing, okay? Because we need, in order to do this, we need to know n, the number of trials, x, the number of successes, p, the probability of that success, and q, the probability of that failure. And then once you have all of that, you can just plug it into the formula and work it out. So why don't you go ahead and give that a shot. So first of all, what is n in this problem? How many trials are there? 10. There's 10 people selected, right? How many successes are we looking for? 3. 3 that go to the doctor last month. The probability, what's the probability that someone goes to the doctor?
0.2.
0.2 or?
1%.
Or?
0.2.
Or as a fraction? 1/5, thank you. So what's the probability of failure then? If 1/5 is the probability of success, 4/5. So that's what you should have had. Now, if you did make this 0.2 and 0.8, that's totally fine. All right. How many had those 4 correct?
Can you explain it to me then?
Okay, sure. So in this example, there are 10 people selected. So that's the total number of people that we're trying to figure out if they went to the doctor. So that's why our number of trials, so to speak, is 10. We want to know the probability that 3 will have visited. So that's considered the success. So we want to have 3 successes. All right, and then we see here that it's 1 out of 5 go to the doctor. So that's the probability of them actually going to the doctor, and also that being considered a success. And of course, the probability of failure is just 1 minus the successes, and so that's where that all comes from.
Yeah, I did 3 over time.
Okay, so how many had that to begin with? All right, not very many of you. So at this point, if you have, since based off of that, go ahead and take those numbers, plug them in the formula, and work through it. If you want to convert this to 0.2 and 0.8 as you work through your example, that's fine. I do want your final probability as a decimal with 2 decimal places to the 100th place, okay? What'd you get? What'd you guys get for answers? Just shout them out. What'd you get?
0.20.
0.2? Anybody else get something different?
Are we not supposed to?
Okay, so here's your formula. Here's how it should look. Now notice over here, I wrote the probability of the number of successes. So this means probability of 3 successes. So that's part of the notation. You want to put that in there. Okay. Everything else, again, we've got the combination of 10, choose 3. The probability of the success. That's going to happen 3 times, and the failure is going to happen 7 times. Okay. How many had that set up correctly?
I did decimals.
Good. Yeah, and if you use decimals, that's fine too. All right. I think I went straight to the answer. So you should have got 0.2. Which, here's something that's kind of interesting. Let's think about this for a second, right? We would expect the probability of exactly 3 people going to the doctor last month at 0.2 or 20% or 1/5. And so 3 out of 10, since 3 out of 10 is close to 2 out of 10, because in reality this is 2 out of 10, we expect it to be very close to that same amount. Okay? If we wanted to have 5 successes, we would expect this number to go down. Okay? Because the reality is it's only 1 in 5. If this would have been 2, it would have been, because this was 0.20 and it kept going, right? This is rounded. My guess is if we put 2 here, it would be exactly 0.2. But anyway. All right. So that's how you're going to work through these problems. You've got to go through and figure out what the success is, what your probability of that success is, how many trials there are, that kind of thing. Okay. One of the things I want to mention about this is as you work through your problems today, there's going to be some that say the probability of at least 3. Okay. If it said at least 3, that means there could be 3 or 4 or 5 or 6 all the way on up. You have 2 options for something like that. You could take the probability of 3 plus the probability of 4 plus the probability of 5 and add those all up. In a case like that, it might be easier to take the probability of 1 plus the probability of 2 and subtract that from 1. Okay, so you have some options when you hear at least. You can subtract the ones that are not from 1, or you can add up the ones that are. Okay, so keep that in mind as you're working through your homework today. Let's talk about mean variance standard deviation. Okay, in a second, I'm going to show you the rest of what's underneath that brown bar, so you can take a picture of that if you wish. But there's really 2 formulas that you're going to have to memorize. They are not hard. And I say 2 formulas because we know the standard deviation is still just the square root of the variance. So you really have to learn these 2 formulas, and then to find the standard deviation, just take the square root of what you got for the variance. So here it is. So if you want to take a picture of that, or if you want to write it all down, you can. Here's all you need to know. Okay? Just like in the other problems where we identified x and n and p and q, in this case we just need n, p, and q. We just don't need the x part in order to figure these things out. But a lot of the times what's going to happen is you're going to have a problem like the one we just did, and then they're also going to ask you not only to find that specific probability, but to find the mean and the variance and the standard deviation. Real straightforward. Okay, the mean is just n times p, so the number of trials times the probability. Okay, so it's actually pretty similar to what we were doing before, where we had the outcome times the probability. In this case, we have the number of trials times the probability. Variance is just we multiply the number of trials times the probability of success times the probability of failure. That gives us the variance, and then for standard deviation, we just square root that. Okay, so let's go through an example of that. Okay. So you need to know what n, p, and q are. Alright. So in this case, they're rolling a die 360 times. We want to find the mean, variance, and standard deviation. So what does 360 represent?
The number, the n.
N, right? The number of trials. Okay. Now, in order to figure out p and q, the probability of success, the probability of failure, we've got to look at this part. The number of 4s that will be rolled. What is the probability that we get a 4?
1 out of 6.
1 out of 6. So that would be which? P or Q? P. So the success rate that we're looking for, this is the probability of getting a 4. That's the success probability, which is 1 out of 6. Well, what's the probability of not getting a 4? The failure. 5 out of 6. Okay. So go ahead and work through both of those, mean and variance.
I got it.
Okay, so this is basically what we just discussed. So here's my setup. I've got the mean, got the variance, sigma squared, standard deviation sigma, and we'll work on getting each of those. Let's look at the mean. Okay, the mean should have been 60. How many had that? Okay. So basically what it's saying is on average we would expect out of 360 rolls that 60 of them would be 4s. which that's 1/6 of that. Okay. How many have the variance already? Okay, so the variance is just multiply all three of them together. Okay, so it's about 50. Okay. It's exactly 50. I don't know why I said about 50. It's exactly 50. So then how do I find the standard deviation? Square root of that. Okay. Square root of 50 is 7.07. How many have that? Yeah, if you round to 7.1, that's fine. One of the things that came up on the quiz yesterday, I did not take points off for the rounding. I've decided it's just not that important. Just, don't make it a whole number. Make it a decimal for a couple places. Even the book contradicts itself when it comes to rounding, so, in general, give me a couple places when you round. I think that's fine. Okay. Any questions about what we just did?